All right, nice to meet you once again. We are going to be looking at some worked examples or some calculations in the preparation of solutions. Now, in our previous class, we talked about what a solution is and types of solution. We also talked about the concentration of a solution. We also went further in that class to discuss what molarity is, or what a molar solution is, and the difference between a mass concentration and molar concentration. Of course, we say concentration in mole per dm cube is molar concentration, while the concentration in grams per dm cube is called mass concentration. Okay, now we also said that a standard solution is a solution that has a known concentration. That is, the concentration of the solution is known. It involves dissolving a particular amount of solute in a given volume of solvent, so to obtain a standard solution of that substance. Okay, now let's look at some of the examples in the calculations involving preparation of solutions. Now let's take a look at our first question for today, and the question is in this form. It says, calculate the molar concentration of solution that contains 0.55 grams of calcium trioxocarbonate 4 in 250 cm cube of solution. Okay, now we are given a particular mass of solute and a particular volume of solvent. So this mass of solute is dissolved in this volume of solvent. Now we are asked to find the molar concentration. Of course, we say molar concentration is the concentration of a solution in mole per dm cube. So let's look at how we can differentiate between mass concentration. We have been given the mass concentration of the substance here as 0.55 grams. So we are asked to look for the molar concentration. That is the concentration of the solution in mole per dm cube when trying to obtain a standard solution. So what they are invariably asking us to do in this question is to obtain a standard solution of this salt. Okay, now let's look at how we can calculate the molar concentration of the solution. Now before we do that, we are going to look at the molecular formula of calcium trioxocarbonate 4 being a compound. We're first of all going to look at the molecular formula of calcium trioxocarbonate 4. So we have our solution to this question as this. So we have molecular formula of calcium trioxocarbonate 4 is CaCO3. So that is the molecular formula of calcium trioxocarbonate 4. Now the next thing we do is to look for the molar mass. So molar mass of calcium trioxocarbonate 4 is, we simply multiply the number of atoms by the atomic masses of the element and we sum them together. So here we have number of atoms of the individual element as this. So we have for calcium, it is 1 atom multiplied by the atomic mass of 40 plus 1 atom of carbon multiplied by 12 plus 3 atoms of oxygen multiplied by 16. So summing this together will give us 100 grams per mole as the molar mass of calcium trioxocarbonate 4. Now, having gotten the molar mass of calcium trioxocarbonate 4, the next thing we'll do is to look at how we can obtain a standard solution of this salt in 1000 cm cube of water or 1000 cm cube of solvent. Okay, now let's look at the question once again. It says 0.55 gram of calcium trioxocarbonate 4 is dissolved in 250 cm cube of solution. Of course, 250 cm cube of solution is not a standard, or when we dissolve 0.55 gram of calcium trioxocarbonate 4 in 250 cm cube will not give you a standard solution. Okay, so we are going to look at how do we obtain a standard solution of this salt. Now, in doing that, we are going to equate the mass of 0.55 grams to 250 cm cube, and we are going to look at the mass dissolved in 1000 cm cube to obtain a standard solution of the salt. Okay, so we have here, we can simply say if 250 cm cube of CaCO3 contains 0.55 grams of CaCO3. Okay, contains 0.55 grams of CaCO3. So if this is that, therefore we can say if 250 cm cube of solution contains 0.55 gram of CaCO3, we can simply say therefore 1000 cm cube of solution will contain 1000 multiplied by 0.55 divided by 250 grams of CaCO3. It is as simple as that. Now, by multiplying and dividing by 250 cm cube, we have our mass as 2.2 grams of CaCO3. So this is a mass that will be dissolved in 1000 cm cube. Of course, this is not our final answer. Our question talks about calculate the molar concentration, that is the molarity of the solution. So we should look for the molar concentration of the solution, and we say molar concentration is measured in mole per dm cube, and it is the amount of solute in mole dissolved in 1 dm cube of solution. Okay, so we can simply say molar concentration is equal to mass of CaCO3 divided by molar mass. Okay, molar concentration is equal to mass of CaCO3 divided by molar mass. So this will give you 2.2 grams divided by 100 grams per mole. Of course, by dividing this, what we have as our answer is 0.022 mole. Okay, or equal to 0.022 mole per dm cube. Okay, so that gives us the molar concentration of the solution. All right, so this is our final answer. The molar concentration of the solution, or the concentration in mole per dm cube, as 0.22 mole per dm cube. Okay, so that is our final answer for this very question. It is very, very simple. Now let's take a look at our second example. Our second example is in this form. It said, how many grams of CaCO3 will be required to prepare a 200 cm cube solution of 1.5 mole CaCO3 solution? Okay, now we have been given here the molarity of the solution. We also been given the volume of the solvent. Okay, so we are asked to find the mass in grams. Okay, so let's have our solution to the question. Let's have our solution as this. So we can say 1.5 mole of CaCO3 contains 1000 cm cube of solution. Okay, so that is 1000 cm cube of solution. 1000 cm cube of solution is equal to 1.5 mole of CaCO3. So therefore 200 cm cube of solution, 200 cm cube of solution will contain 200 multiplied by 1.5 divided by 1000 divided by 1000, and this will give us 0.30 mole of CaCO3. Okay, so this is the molarity of the solution when it is dissolved in 200 cm cube of the solution. Now we are asked to look for the mass in grams of CaCO3. That is the mass concentration of CaCO3. And remember we said molar concentration is equal to mass concentration divided by molar mass. So if from that relationship we can simply look for the mass concentration, or we can simply look for the mass of the solute. Okay, so we can say mass concentration equal to number of moles multiplied by molar mass. Of course, the number of moles here is 0.3 mole multiplied by molar mass is 100 grams per mole. Okay, so here we can have 0.3 multiplied by 100 will give us 30 grams of CaCO3. So that is our final answer as a mass of calcium trioxocarbonate 4 that is dissolved in 200 cm³ of solution. So that is the end of this question. That gives us the molar or concentration or the molarity of the solution, or that is how we can find either the mass of the solute when you are given the molarity, and you can also find the molarity or the molar concentration when you are also given the mass. So these are simple calculations that we can have in the preparation of solution in terms of molar concentration and mass concentration. So with this, we will come to the end of this class. I hope to see you in our subsequent class, where we are going to be looking at further examples involving neutralization reaction, or in quantitative analysis or volumetric analysis. We are going to be looking at further or more complex examples on calculation or on preparation of solutions. So I hope to see you in that class. So bye for now.